Today we'll be finishing the section 6.3 notes. So last time we had talked about using the binomial theorem to expand polynomials. So let's start with a quick example of this. So let's say we have 2x minus 3 to the third. So the formula that we're going to be using is for a plus b to the n. We have n choose 0, a to the n, b to the 0, and then n choose 1, a to the n minus 1, b to the 1, and we keep going all the way down until you have n choose n, a to the 0, b to the n. So here, our n is 3, our a is 2x, and our b is negative 3. So we're going to have 3, choose 0, 2x to the third, negative 3 to the 0. And then we'll now do the same thing, but this number will increase 1, this exponent decreases 1, and that exponent increases 1. So we have 3, choose 1, 2x to the second, negative 3 to the first, and then we just kind of keep going, continuing this process until we have n choose n, which is what we have here. So this will be the last one. Okay, and now what we'll do is map that off, and we'll type this stuff into our calculator now. So it's nice because this combination command is on our graphing calculator. So I'll type in 3, I'll press the math button, move over to the PRB menu, and then choose the NCR command. So I already have the 3 there. I'll type in 0, and do a times, and then I have a 2 here attached to my x. I can't type x's into my calculator, or I would type in 2x, but I can't do that. To the third times, and then I'll do the negative 3 to the 0. If I press enter, that gives me 8. So what that tells me is that 8 is my first coefficient, and then my variable part is x to the third. And I'll do that for the next piece. So rather than typing all that in over again, I can press second and enter and just go back and edit things, because the only thing that's changing is this exponent moves from a 0 to a 1. This exponent moves from a 2, or from a 3 to a 2. And then this subscript changes from 0 to 1. So now I have minus 36x squared. Again, why x squared? Because of that. And then I'll continue doing this. I'll press second and enter, and do my updates again. This changes from 1 to 2. This changes from 2 to 1. And this changes from 1 to 2. So again, just updating what I have written here. Again, went from 1 to 2, from 2 down to 1, from 1 up to 2. And that's what I typed in. So that's going to give me 54, and then x to the first, or just x. And then my last one, second enter, moves to 3, down to 0, up to 3, press enter, get negative 27. So that's my final answer. So that's just a review of what we talked about last time before break. Today, what we're going to talk about is using a binomial experiment to calculate probabilities. So a binomial experiment is something where it has 2 possible outcomes. Success or failure. So think about like flipping a coin, like either it lands heads or tails. There's only two possible outcomes for that. Or if you're like playing a slot machine, you either win or you don't. You know, so things like this, right? There's just two outcomes, success or failure. We call the probability of success, we abbreviate that with the lowercase letter p. And we call the probability of failure, we abbreviate that with the lowercase letter q. And we want to make a note, since there's only two possible outcomes, the probability p is equal to 1 minus q, or you can say the probability q is equal to 1 minus p. Why 1? Because there is a 100% chance of something happening, and if there's only two outcomes, it's going to be one or the other. Keep in mind that when we write these p's and q's, writing these as decimals rather than as a percentage. Okay. So we can say then the formula, so this is the uppercase P, so our formula, probability of exactly our things happening, or exactly our successes, in this case, is n choose r times p to the n minus r times q to the r. So let's look at an example then of this. Okay. So let's say that we have the following situation. We're told that 1 in 5 boats traveling down the river bypasses a harbor at the mouth of the river and heads out to sea. Currently, 4 boats are traveling down the river and approaching the mouth of the river. So, in this case, my P is going to be equal to probability of stopping at the harbor. That means Q is the probability of going out to sea. We're told in the problem that the probability of stopping at the harbor is going to be we're told actually that the probability of going out to sea is 1 in 5. So 1 out of 5, or 0.2, because it says 1 in 5 boats bypasses the harbor and heads out to sea. So that means the probability of stopping at the harbor is 1 minus 0.2, or 0.8. Now, for the sake of this problem, does it really matter which one I labeled as my P and my Q? It doesn't, as long as you kind of use that same P and Q as you're given more information. Okay. What will my N be? Well, it says there are 4 boats on the river, so we have N equals 4. Now let's ask some questions about this situation. So part A might ask, what is the probability of exactly 3 boats stopping at the harbor? Okay, well, that means capital P of the probability of exactly 3 is going to equal N, choose 3, P to the 3rd, times Q to the N minus 1. Is that what I wrote down up here? Oh, Billy, this is wrong. Should be Q to the R. or p to the r, q to the n minus r. Yeep! Good thing we caught it. So, to do this, I'm just going to go type in my calculator. And I get about 41%. What if we change this to say what is the probability of at least 3 boats stopping at the harbor? Well, instead of p of x equals 3, because it says exactly 3, here it says at least 3. So that means we have greater than or equal to 3. So in this case, that could be p of x equals 3, or x equals 4, because again, we're told there's only 4 boats traveling on the river. So there's a property of probabilities. It's called the law of mutual exclusion. Your textbook calls it the addition rule for mutually exclusive events. Anyways, it says if the events are mutually exclusive, meaning that they can't happen at the same time, like I can't have 3 boats stopping and also 4 boats stopping all at the same time, we can treat this as an addition problem. So the or really becomes an addition. Oh, okay. So this we can do. This is just 4 choose 3, p to the third, q to the first, plus 4 choose 4, p to the fourth, q to the 0. And I can go to my calculator and type that in. So since I'm going to use this piece that I typed in earlier, I'm going to press second and enter. It puts that whole thing up on there for me that I can now edit. And then I'll say plus 4 choose 4 times 0.8 to the fourth times 0.2 to the 0. And that gives me about 82%. Last one, we might say, what is the probability of at most 3 boats stopping at the harbor? So at most, well, that is p of less than or equal to 3, right? At most 3, so that could be, in this case, p of 0 plus, it could be 0 boats, 1 boat, 2 boats, or 3 boats. Jeepers creepers! So that would mean I'd have to do p of x equals 0, plus p of x equals 1, plus p of x equals 2, plus p of x equals 3. And that gets to be kind of a lot of typing in my calculator. Not that I couldn't do it, but it's a little bit time consuming, and there is actually a faster way to do this. This faster way to do it is called the complement rule. And what the complement rule says is that if I go back to the original, oops, let's not use black, though. I'll pick a different color. This is the same thing as everything, the 100%, minus whatever is not in there. Well, in this case, what are the things that are greater than 3? Well, there's only 4 boats on the river, so it's just 4. Oh, well that's pretty easy. So if you didn't understand what this rule is really saying, imagine this is like a little bit easier to understand scenario. So let's say we know that the probability of getting heads 3 times out of 4 is 17%. If I want the probability of that not happening, I can just do the 100% minus the 17, and that's going to give me everything where that doesn't happen. Correct? That's the same idea that we're using here. So it's just the 100% minus the stuff that doesn't. Oh, okay. That seems not quite as daunting. And that's much easier to type with my calculator. So if I pull that guy up, and I do 4, choose 4, oh boy, press the wrong button there, times 0.224 times 0.220, I get about 41%. And I'm finished. And that's basically the gist of it for this section. So your assignment will be section 6.2. So your assignment is in section 6.3, excuse me, 3 to 13 odds, and then 15 to 22 all, and then 26. Good luck.